Let's talk about evaluating functions. So remember that we have this basic idea that if we have a function notation, that's the same thing as y. So when I write my equation as y equals x squared minus 6x plus 8, I could also write this as f of x equals x squared minus 6x plus 8 using that function notation. So let's evaluate this for some different values. Let's start by finding f of 3. Well, remember that f of 3 means that wherever I see the x, I replace it with a 3. So that's going to give me 3 squared minus 6 times 3 plus 8. Well, 3 squared is 9. Minus 6 times 3 is minus 18 plus 8. 9 plus 8 is 17, so it's 17 minus 18, which is minus 1, which means that in this particular case, since I have an input and output, I have a point at 3 minus 1. Now, let's continue this. What if we have g of minus 2? Then we're going to get minus 2 squared minus 6 times minus 2 plus 8. That's 4 plus 12 plus 8, 16 plus 8, which is 24. So I get a point at minus 2, 24. We could also evaluate this for fractions. That shouldn't be an f, g, it should be an f. We also have f of 1/2. So that would be 1/2 squared minus 6 times 1/2 plus 8. Well, when we look at this one, this is going to be 1/4 minus 6/2 plus 8. And I'm going to leave it in this form because I need everything to be the same. So everything needs to be a fourth, which means this becomes a minus 12/4 times by 2 over 2, because I'm only missing a 2. We'll times this one by 4 over 4, which is plus 32 over 4. So I get 33 over 4, adding the positive ones, minus 12 over 4, which is 21 over 4, or we have the point 1/2 21 over 4. So it's perfectly acceptable to plug in fractions when we work on these problems. Now, the other thing that sometimes catches students up is that it's also possible to evaluate a function. Remember, f of x equals x squared minus 6x plus 8. It's perfectly acceptable to evaluate this at something like a plus 2. We just do the same thing. Wherever we see this variable, we replace it with this one. And so f of a plus 2 is a plus 2 squared minus 6 times a plus 2 plus 8. This, I'm going to use the perfect square trinomial of the first one squared plus 2 times the first one times the second one plus the second one squared minus distribute a 6a minus 12 plus 8. Well, this is a squared plus 4a plus 4 minus 6a minus 12 plus 8. If we combine all of our like terms, we have just an a squared by itself. 4a minus 6a is minus 2a. 4 plus 8 is 12. 12 minus 12 is 0. So f of a plus 2 is a squared minus 2a, or we get the point a plus 2, a squared minus 2a. And then we just need to know what a was in order to go any farther than that. But one of the interesting things here is notice that we've just converted from our nice x value to an a value. We've just changed the variable by doing this. And the last one, and this one will come up soon, is suppose that we want to do this with f of x plus h. Well, that works much the same way. We get x plus h squared minus 6 times x plus h plus 8. Well, again, the perfect square trinomial formula is x squared plus 2xh plus h squared minus 6x minus 6h plus 8. Since I used an h instead of a number, nothing comes of it, and this is what we get. And this gets used later on in this chapter, so pay very close attention and make sure that you're comfortable evaluating for a different variable with maybe some other number being added to it, or the same variable with something being added or subtracted from it. But whatever's in parentheses, we plug in for the original x and replace it, and then work through and evaluate as far as we can.